Robots have moved from the realm of science fiction to a crucial part of our daily lives. Whether in manufacturing, healthcare, or even at home, robots are shaping the future. But have you ever wondered how they're made and how they actually work? In today's video, we'll dive into the fascinating world of robotics, from their creation to their function. And we'll even discuss how you can build your own robot. First, let's define what a robot is. A robot is a machine capable of carrying out a series of actions automatically, especially by being programmed by a computer. Robots come in many shapes and sizes, but they all share a core purpose. They perform tasks that are typically repetitive, dangerous, or too complex for humans. In simple terms, robots are designed to help us. They can be programmed to follow specific instructions, execute certain tasks, and interact with their environment. The best part? Many modern robots are capable of learning and adapting to new situations. Before diving into how robots are created, it's important to understand the different types. Broadly, robots can be categorized into industrial robots. These are used in factories and warehouses to automate tasks like assembly, welding, and painting. They're fast, precise, and built to handle heavy-duty tasks. Service robots. These include robots that help in hospitals, homes, and other settings. Examples include robotic vacuum cleaners, surgical robots, and delivery robots. Humanoid robots. Designed to mimic human appearance and behavior, humanoid robots are often used in research, education, and entertainment. Autonomous robots. These robots can operate independently without human intervention, using sensors, cameras, and AI to navigate and make decisions. Self-driving cars are a prime example. Robots are made up of several key components that allow them to function. Sensors. Sensors help robots perceive the world around them. They can detect light, sound, temperature, pressure, and more. This allows robots to interact with their environment, understand their surroundings, and make informed decisions. Actuators. These are the components that allow the robot to move. Actuators convert energy into mechanical movement. They could be electric motors, hydraulic cylinders, or pneumatic actuators. Controller, processor. This is the brain of the robot. The controller processes the information from the sensors and sends commands to the actuators. It's essentially the robot's operating system, power supply. Like any machine, robots need energy to function. This is usually supplied by batteries, electricity, or in some cases, even solar power. End effectors. These are the parts of the robot that interact with the environment. For example, a robotic arm might have grippers or tools that manipulate objects, much like a human hand. The creation of a robot involves several stages. Here's an overview of how it works. Design and planning. The first step is designing the robot. Engineers and designers decide what type of robot it will be, what tasks it will perform, and how it will look. CAD, or computer-aided design software, is used to create detailed three-dimensional models of the robot and its parts. This is where decisions about the robot's structure, size, and components are made, building the hardware. Once the design is ready, the robot's physical components are created. This involves creating the robot's body, installing actuators, sensors, and end effectors, and assembling all the mechanical parts. In industrial robots, this can be highly automated using CNC machines, three-dimensional printers, or traditional manufacturing methods. Programming. A robot won't work without software. Engineers write code that tells the robot how to perform its tasks. This could include low-level control code for movements, high-level AI algorithms for decision-making, and software for sensor integration. This step is critical as it enables the robot to respond to its environment, process input, and take action. Testing and calibration. Once assembled, robots undergo extensive testing. Engineers check for issues with movement, sensory input, and overall performance. Calibration ensures that sensors and actuators work within the correct parameters. Testing also involves real-world scenarios to ensure reliability and safety. Now that we know how robots are created, let's talk about how they function. A robot works by continuously gathering data from its environment through sensors. The controller processes this data and determines the appropriate action. For example, a robotic arm in a factory might use vision sensors to detect parts on a conveyor belt. It then uses its actuators to pick up the part, move it, and place it at the correct position. In autonomous robots, artificial intelligence plays a significant role. These robots don't just follow preset instructions, they can learn from their experiences. They analyze patterns, adapt to new situations, and make decisions based on past actions. A good example of this is how autonomous cars work. They gather data from cameras, LiDAR, and radar and use AI to navigate traffic, avoid obstacles, and make driving decisions. Creating your own robot can be a fun and educational project. Here's a simple guide to get started. Choose your robot type. Decide what type of robot you want to create. It could be something simple like a line-following robot or a more complex humanoid robot. Gather materials. You'll need some basic components. A microcontroller like Arduino or Raspberry Pi motors and wheels if you're building a mobile robot sensors, such as ultrasonic or infrared A power source, like a battery or power supply wiring and connectors, optional three-dimensional printer or pre-made robot kits for more complex designs. Assemble the robot. Begin by connecting the motors, sensors and microcontroller. You'll likely need to build a frame for the robot to hold everything in place. Write the code. Programming is the most crucial part. You'll write code to control the robot's movements, response to sensors, and any actions you want it to perform. If you're using Arduino, the platform provides a lot of resources for beginners. Test and iterate. Once the robot is assembled and programmed, start testing. It's likely that you'll need to tweak both the hardware and the code to get everything working just right. There are plenty of online tutorials and communities where you can find guidance, whether you're a beginner or looking to build more advanced robots. And if you don't have the materials for building one from scratch, you can also explore robot kits available for all skill levels. The future of robotics is incredibly exciting. We're already seeing robots perform tasks like surgery, assist with elderly care, and even explore outer space. As artificial intelligence continues to advance, robots will become more autonomous, efficient, and intelligent. In the future, we might see robots working alongside humans in every industry, making our lives safer, easier, and more productive. And with the rise of DIY robotics kits, the next generation of engineers and creators will likely be able to build robots right from their own homes. Robots are complex and fascinating machines that are becoming more and more a part of our daily lives. Whether you're interested in how they work or you want to create your own, robotics offers endless possibilities. I hope today's video has given you a better understanding of how robots are made and how they function. Thanks for watching. And don't forget to explore the world of robotics. Who knows? Maybe you'll build the next great robot.